Well, getting back to these shelters, if you're in there any length of time, can you grow food with artificial light? Could you sprout seeds? Is that something people are doing?
Sprouting seeds is a good idea, and taking seeds. If you had enough power to provide grow lights to grow plants on artificial food, I would be quite surprised, because it takes quite a lot of energy to provide the light that you need to grow. It's quite possible, it's quite feasible, people are doing it, but you have to think of how long the growing season is and what kind of a fuel supply you would need for your electric generator to provide the lights. So I don't think it's a very practical idea.
So you better have what you need.
Yes,
plan.
And an emergency generating equipment for minimum electrical needs. But it would be a very unusual situation that it would be worthwhile to burn fuel, generate electricity, provide light to grow plants underground.
If for some reason you ran out of water, is there any kind of a purification system that filters out radioactive material from surface water if you became desperate?
Yes. Actually, any kind of ion exchange system will remove almost all of the radioactive material from water, contaminated water. And it turns out that ordinary dirt is a fairly effective ion exchange media. And so all you have to do is take a bucket, fill it with about 6 inches of dirt, and make sure that you dig down below the surface layer so the dirt you use is not contaminated itself. And punch a few holes in the bottom of the bucket, then fill it with your contaminated water, let the water percolate very slowly to the 6-inch layer of soil and out the nail holes in the bottom of your bucket, and that will remove almost all of the radioactive material that's in the water. It's quite simple to do, a little bit tedious, and the water comes out murky brown from the, but it's you can then filter it through a paper towel or something to take out the soil particles, which are right above your nail holes, which come through, and it's quite drinkable and quite safe.
So you recommend that be a part of the preparation in the shelter?
You should make plans for obtaining emergency water supplies, yes, and all kinds of emergencies, and that's a simple method. There are also pressure pumps that force water through microfilters that will take out the fallout particulate matter out of water, and these are quite effective and work good, but they're not nearly as cheap as a bucket half filled with dirt.
I understand that bentonite clay has a tremendous absorption capacity. Would you put any of that in with the ordinary dirt?
If you have it, yes. And clay is better than sand, and bentonite is the best of the clays. And if you happen to be lucky enough to be in a locality where you have good clay, of course that's the best choice. And buying and keeping on hand a few small sacks of bentonite clay is a very practical idea, I think.
Why don't we get into the cost considerations of the shelters you recommend for the ideal family of 4, or even for 15 to 25 people, if you think that would be an advantage to have a larger shelter?
The economics of shelters are best at a shelter designed for about 20 people. That is, if you initially design the shelter to house 20 occupants, your cost per occupant is about the lowest. If your shelter is designed only for your own family, say 4 or 5 people, it will cost more for each occupant. The reason for that is the expense of the blast doors and the blast valves and the air entrainment system and the life support items that you have to have. A blast door costs the same whether it goes into a shelter for 4 people or a shelter for 20 people. So you allocate the cost over more occupants when you have a slightly larger shelter. So if you're in a neighborhood or you have close relatives, then the lowest cost for a group would be to design around 20 people. And you can then gang the shelters together if you like. In fact, the Swiss do this. They have one walkway or tunnel, and they branch off a number of shelters off of this one main entranceway. And that works very well in a country where it's more crowded than we are here. The lowest cost that for the materials for a good blast shelter, either corrugated metal or reinforced concrete, the materials alone are going to cost you in the neighborhood of $300 to $400 for each occupant. We've never been able to figure a way to get them any cheaper than that. If you can do all of the labor yourself and have no other costs, then that would be your total cost of the shelter. Normally, we expect the installed cost of the shelter to be at least twice the material cost and probably 3 times the material cost. So for a good permanent dual-use shelter, your expected costs are in the neighborhood of $700 to $1,000 in today's prices for each occupant. You can make expedient shelters much less cost than this, as low as $50, in the range of $50 to $200 per occupant will make expedient shelters that are quite good for protection from fallout.
What I'd really like to ask you, besides all these details which you've very adequately provided, is if you were in charge of the civil defense for the United States, had the budget and Congress behind you, what plan of action would you institute right now?
All right. If the budget were available, all right, I would recommend implementing the manufacture of corrugated metal shelters, shipping and distribution to communities, and then the local assembly and emplacement and covering of these corrugated metal shelters. And in cities where the population density, there's not enough open space, then there would have to be a different program to upgrade the below grade basement levels to make shelters out of those, to build shelters in under the available parking lots. In fact, the parking lots in cities, when we looked at it, are one of the best places to build underground shelters. There are a surprising number of places to park cars in lots and off the streets, and almost all of them are suitable for large underground shelters. And there would have to be, with this, a plan to provide for industrial recovery. Because to properly feed and care for the population, we have to be able to recover the industry. And there have been studies and tests on this also, and it's quite technically feasible to recover our industry rather quickly to the levels that will provide population support.
Well, we hope that in the very near future you will be a part of such a team that does take what we have in the planning stage and in the technology into action. We also want to thank you for being the flame of freedom that speaks at Summit University Forum.
I'd be happy to answer questions that the audience might have.
That's what we'd like to do right now.
Very good.
I have 3 questions. First, I wonder if you would comment on what measures should be taken to protect your entrance from radiation entering into the shelter and from blast entering the shelter. In other words, the entrance to the shelter, what measures can be taken to secure that, to make sure that radiation doesn't get in?
On the entrance to the shelter, it's important that you prevent any straight line of sight for the radiation to come in. That means that the shelter entrance has to have bends in it to help block the line of sight for the fallout radiation. One 90-degree bend in your entrance gives you a protection factor of about 10. 2 bends would give you a protection factor of 100. Actually, you also get protection because the solid angle presented by the entrance is much less than the 180-degree solid angle available to the outside ground level. So normally we recommend one 90-degree bend and then a shielding door in your blast door, which provides about another factor of 10 shielding. Then the solid angle, because your entrance is only a small part of the total view of the shelter itself, provides about another factor of 10. So these together give you about a factor of 1,000, which is what we recommend. The shelter entrance also has to be covered everywhere so that you also have the factor of 1,000 shielding for the radiation, which would come directly overhead down through your entrance and into blast door into your shelter. So you have to be somewhat careful in designing your entrance to provide the overhead shielding, provide a line of sight right angle bend, and then some shielding in the blast door or a supplementary door. You also need to be somewhat careful the way your door opens so that it's not easy for it to be jammed by debris, because the blast winds will throw and roll a great many objects, rocks, automobiles, houses, everything gets thrown and scattered and will end up in your shelter entrance. So be careful that you can open the door against this debris. Now, it's not good to have your door opening inward. The reason is to stand the blast forces, you need to have the full jam around the periphery of the door from the outside forces to take the loads. And if you open the door inwards, it makes it easier to open. It can't be plugged by debris, but then if you have to have enough dogs or latches or hold downs around the perimeter of your door to take the blast loads. So it's far easier to have it open outwards. That gives you a full perimeter jam. Then make sure that when you force the door open, there's room so that the debris in front of it can move. You don't want your door tightly jammed up against another wall, so that if you try to open it, you've got the debris pushing against the wall, which is keeping you from opening it. So you want a fair amount of run space in front of your door, so that means your right angle bend has to be a fair distance away from your door.
The second thing I was interested in was if you did not have an electric generator and a fuel source inside or adjacent to the shelter, how would you go about providing some kind of power to run your ventilation system and lights?
The easiest way to run your ventilation system is with some kind of manually operated fan or pump. There are available commercial pumps, either hand operated or bicycle operated. And of course it's preferable to use the large muscles in your legs. Bicycle is a far more satisfactory method of transmitting power than from a hand pump. If an expedient way of pumping air has been developed by Crescent Carney and is described in his book called the Kearney air pump. And you can make out of a few pieces of boards, some light plastic, and some string, you can make a louvered fan that is quite effective in moving air. If nothing else, you can use a bed sheet or a large sheet of cloth, and two people, one on each side, simply move the sheet and pull the air behind it through the shelter, and that will pull air in through the air inlets. And then you fold the sheet up and walk back to the other end of the shelter and unfold it again and pull it back, or you don't have to walk the full length of the shelter, just move it back and forth. It's really quite effective. For electrical power to run small appliances, the most satisfactory way is to have a small generator. The little gasoline generators provide enough electricity for most small appliances, and have fuel to last you as long as you expect to need it, and locate the generator where your air exhaust is so that the fumes go out the exhaust and not into the shelter. Also, bicycle operated generators are available. In fact, almost every bicycle shop have little clip-on generators that you can mount on the bicycle tire to operate lights. These can, on your bicycle, these can also be used to charge up a battery, and then the battery in turn to operate your electrical appliances.
Thank you. The third thing I was interested in was some people might have the idea of using a septic system, say an existing septic system, to dispose of wastewater and so on from the shelter. And I'm wondering if it could be expected that nuclear fallout on the surface could be substantial enough to, say, kill the bacteria in the septic tank that it depends upon for making that kind of a system work. Have you ever looked at that?
Yes, and it doesn't appear to be a serious problem at all. The main difficulty is providing a manual pump, because generally where your shelter level is located will be below the level of the inlet to your existing septic system. But boat supply houses have such pumps. They're available from camping supplies and so on. So if you have a pump to lift your sewage up into the septic system, it doesn't appear that the fallout radiation is a significant hazard to the normal bacteria. The reason for it is the bacteria are distributed throughout the system, and they're very prolific. The ones down at the bottom of your existing septic system have not only the earth shielding over it, but also the full depth of your septic tank of water for shielding. So the ones at the bottom are quite protected, and even though the ones at the top might be killed off, they very quickly replenish themselves.
Thank you.
Do you have any knowledge of ultraviolet effects after a nuclear detonation? There's some talk of excess ultraviolet radiation affecting crops and growing. Are there any studies that you know of that are in existence that have any information on this topic?
Studies have been made. One of the products of a nuclear explosion is the creation of ozone. The ozone, and prior to that, the nitrous oxide, when these are lofted up to the top of the atmosphere, the nitrous oxide may interfere with the natural ozone layer and decrease it to some extent. Some of the ozone created by the detonation itself may help to replenish it, but it appears to be that the loss of ozone dominates. The amount of increased ultraviolet radiation from the past weapons testing was on the verge of being discernible. Some 200 megatons have been detonated in the atmosphere by a combination of the United States and the Soviet Union. And that amount of material lofted into the stratosphere, affecting the ozone layer, permitting more ultraviolet radiation, may have been detected. Some people say yes, some people say it was within the range of normal variation month to month and year to year. The increase in, if there was a major exchange, there should be an increase in the ultraviolet radiation at the ground level. It's probably equivalent to the change in ultraviolet that you get from going from sea level to mountain elevations. Whether it will affect crops or not is one of the topics of concern. It may affect the kinds of crops that will grow at a particular elevation. It may not. We really don't know the magnitude of what the change might be. I think it's likely to be in the range of the normal year-to-year variations and the normal variation from sea level to mountain elevations. Whether that will have an effect on the length of the growing season, the kinds of crops that mature and the kinds that don't mature, is one of the problems that there are no clear-cut answers to today. And some people take the pessimistic view and say, since we don't know exactly what will happen, it's bound to be catastrophic. There are other people, myself included, who feel that the Earth's atmosphere is very self-healing. It's managed to survive through the glacial periods, through periods of volcanic activity, through gigantic forest fires, through the man-made pollution of the last few decades, with effects that we're just barely able to detect today. So I don't think the effects are likely to be very serious. But it is an area under study. People are studying it, trying to get quantitative answers, and we simply don't have the quantitative answers today. I'm sorry.
The second question I have regards psychological studies done on people in shelters. Are you aware of any printed information that we may be able to get a hold of on what has happened to people when they're confined over long periods of time in such a stressful situation as not knowing what may be happening?
There have been such studies, quite a number of them, in fact, both analytically and actual experiments with selected groups of people. My memory isn't good enough to give you the actual references to them, and I could point you in the directions of some of the literatures about the best I could do now. What the general tone of the studies and experiments have been that activity is extremely important. That's one of the findings of the Swiss study, and it's been confirmed by U.S. Army studies and by submarine crews in the U.S. Navy and so on, that if the shelter is too cramped and you're not able to move about, run, do calisthenics if you want to, and run in place and so on, that it becomes very disturbing to people. And so that's one reason for having enough shelter space. And the U.S. criteria is 10 square feet of floor space, 80 cubic feet of volume for each occupant, and the ability to do things, to be active. A part of that also is having some information of what's going on. That's why communication is so important, and that's why instrumentation to measure fallout is so important, because to be afraid to go out, to not know whether it's safe to go out or not, is very difficult to live with. So the information is greatly helpful. Even with this, there are some fraction of people who are going to panic or going into hysteria or some other reaction out of the normal. The studies on the estimates of this run from 5% to 15% of the occupants of a shelter will have uncontrollable behavior problems that are going to require other people to monitor them and keep them from harming themselves or harming others. That's one of the other reasons for having more people in a shelter, because and again, the number of 20 or so seems like a good number. It's large enough that there are going to be a number who remain completely sane and capable of making rational decisions, in spite of a few who may go into hysteria or into panic, and so we'll be able to keep the whole group under capable control. But there are going to be some aberrations, and there seems to be no way of avoiding that in the human population.
Thank you. The third question that I have regards diseases in closed spaces. I believe that the Navy or somebody had done some research putting a number of people into a shelter, and that they all, by the time a month was over, they all wound up with various types of fungus diseases. I was wondering if you had any other information on that topic.
It's a very good point you brought up, yes. Sanitary provisions, first aid provisions are extremely important, and the humidity that can develop in shelters is one of the real hazards. It's one of the reasons that we continually stress good ventilation system and a good air supply to keep the humidity down, because the same conditions that caused trench foot in World War I and in the Aleutians in World War II and in the jungles in World War II, that's primarily caused by high humidity, moisture inside your shoes, and inability to get dry. And so you have to have the ability to keep dry, keep your skin dry, be able to at least take sponge baths and that sort of thing. So maintaining hygiene and sanitation inside the shelter is extremely important. And if you relax, there are going to be a large number of fungus, skin rashes, that kind of thing. So the way to prevent them are cleanliness, being able to dry, being able to take sponge baths, keeping clean, keeping your clothing clean, and so on.
Thank you.
I was wondering if you're familiar with any studies that have been done on adapting caves or caverns for possible shelter environments.
Yes, there have been a number of studies looking at this. Part of the National Shelter Survey study conducted by the government has identified a very large number of mines and caves. Probably the outstanding example of this are the limestone caverns in Kansas City. These are enormous areas underground, thousands of acres of land where they mine the limestone to provide the aggregate for the concrete that built the streets of Kansas City. People have looked at this as a place for mass sheltering of the people in that area, and it looks very feasible. All that's required is an emergency tower to provide ventilation fans, because the shelters go for almost miles, it seems. Actually, it's like a quarter of a mile to a half a mile back from the entrances, so there would have to be forced ventilation throughout the shelters, and then blast doors to keep them out, to keep out the blast. There are similar type mines and caverns throughout the West and much of the United States, and it takes a very minimum of preparation for ventilation and for blast protection at the entrance to the shelters or mines. A lot of mines are not suitable because of the leakage of methane gas or other gases, and so that's one of the things that you have to check, is to make sure that the cavern or the mine itself is suitable for long-time occupancy, or else have enough ventilation to overcome that.
You mentioned the tunnel system in Red China under many of the cities there. Are there any particular problems that you might foresee in a situation where many people would try to occupy a large tunnel-type structure underground?
The problems are similar to the crowds of people that are in our subway systems during rush hours. If you've been on any of our subways in New York City or Washington D.C. in rush hour, you know what the problems are. The subway system, the tunnels in China are normally wide enough to drive a truck down, and so they are wide enough and high enough to meet the psychological problems of people being in them for long times. They will hold more people than the air supply was adequate for. And the people who have gone through the tunnel systems in China say that that's the only deficiency they find, is that if the tunnels are actually crowded to capacity with all the people that could jam into them, then the existing air supply would not be adequate, that humidity would very soon go high, it would become very uncomfortable, and possibly even a health hazard to the people. So the Chinese have been quite interested in ways of improving their ventilation, and once this was pointed out to them, they seem to be taking active steps to correct it, and are making use of some of the expedient fanning methods that have been envisioned and tested here in the United States. Other than the overcrowding and the lack of ventilation, I see no particular problems with their tunnels.
In regards to shelters, in many pictures that I've seen in various books and literature on the subject, there are piping pipes and different tubes that stick up above the ground that I suppose are accesses for ventilation and that type of a thing. Do you have any comment on that? Is there any advice you might render regarding protection of that above ground piping, or alternative ways of resolving ventilation systems? It just seems that they're so vulnerable.
In the pictures, the pipes that you see usually are for the ventilation system, and usually they are too small for the amount of air that you need. Again, that's one of the things you have to consider when you're designing your shelter, is the survivable air supply. If you're lucky enough that you only receive fallout and not very much blast, then there's no problem with the survival of your above ground systems. But the blast wave, may destroy your pipe entrances and so on. And that's one of the reasons that the Swiss, for example, use their emergency escape tunnel as the air inlet system, because on the emergency escape tunnel they go to the trouble of fixing it so it does survive the blast level. It's usually a horizontal tunnel which leads out away from the shelter, then comes up to a manhole through a large grate on top of the manhole, and the grate is strong enough to prevent debris falling down in the tunnel itself, and a large enough area so that even though the air filters through the debris fairly slowly, the area is big enough to provide an adequate air supply. A number of expedient ways of regenerating the air inlet system have been tested. One of them is to have a second pipe in a robust automobile jack, and you simply jack the pipe right up through the ceiling of your shelter and back out into the open. Actually, we build it in place above the shelter roof and have it buried a foot or so below the ground level, and then simply lift it up through the remaining foot of dirt up into the air. And these have been tested on the high explosive blast simulation test, and they work quite well. But your point is a very good one. The air inlets and air exits can be vulnerable, and you have to think about them surviving the blast itself. And designs have been developed and are available in the documents, but it is important to consider it. It's a good point.
Thank you.
Is there any risk in eating packaged food that withstands a nuclear blast above ground? And if there is no risk, what steps should be taken to ensure that it is not contaminated when prepared?
All right, if the package is intact, then the food inside the package has not been contaminated. And almost any kind of package is adequate. A plastic bag, cardboard box, metal can, any of these, as long as the package has not been ruptured, then the food inside has not been contaminated. What you have to be careful of is when you open the package that you don't contaminate the food as it comes out. So what you do is at least dust off the container to get all the visible fallout dust off of it. If possible, you rinse it, wash it off, and then be very careful how you empty the contents so that any material that might be on the package itself aren't allowed to mingle with the contents when you're pouring them out of the package. If you do that, then the contents themselves are not contaminated, and you treat them as you would any other supply.
My second question is, how might one determine that food is safe after food production resumes after a nuclear blast? That would be the food itself, perhaps within a container.
Is your question food that is grown on land that has been subject to fallout? When is that food safe?
Or perhaps we may not know where that food comes from.
There's no way of knowing it's safe without instrumentation. There's no way you can tell by the taste or texture, and so you either have the choice of a monitoring instrument that can detect the radiation and determine that it's safe, or wait long enough, and waiting long enough is a full growing season. And that would mean abandoning the first year's crop, and that probably is not acceptable in a post-attack environment.
So in other words, we may be forced to eat food that's produced in that first year just to survive.
Yes, that may be. And the probability is that it's perfectly safe to eat, because the amount of fallout on the farming land and the amount that's taken up into the food is measurable, but it is probably not life-threatening. But with the absence of instruments, there's no way of knowing for sure.
Is there anything that one might do dietarily to avoid assimilating those radioactive isotopes in the food that may be present after that first year?
As far as you can, limit your diet to food supplies that you have high confidence are safe. Other than that, there's no real way of protecting yourself from a radioactive material that's incorporated into the plant and then into the food that we eat. Some things, like leafy vegetables, where the concern is with the surface contamination, then washing, cleaning is probably adequate. But on cereal grains and fruits, where your concern is with the radioactive elements being incorporated right into the growth of the plant and therefore into the food that we eat, there's no way that I'm aware of that would completely avoid that if you have no way of measuring it. Everything that grows takes up nutrients from the media that it's in, and if the media contains radioactive materials, then those will be incorporated into the plant and into the part of it that we eat. Now the level of contamination is very unlikely that it will actually be a health hazard. But if you have no choice, you go ahead and eat it, of course, whether you know whether it's safe or not. But the only certain way, and the only way to feel certain about it, is to have some way of measuring it.
My last question would be, is there an effective low-cost radiation meter to determine radiation levels outdoors as well as perhaps in food or water after one comes above ground?
Well, the key to the question is low cost, and the lowest cost one is one you make yourself out of a tin can and some pieces of aluminum foil. In high school, most of us were exposed to an instrument which we called an electroscope, which had two fine metal leaves, sometimes of gold, and you charged it with static electricity by touching a knob on top of the chamber, and the leaves then repelled each other. They stood apart, and then ionizing radiation would ionize the air in the electroscope chamber, and the leaves would come back together. You can make one out of nothing more than household aluminum foil and a can to hang them in, some gypsum, plaster of Paris, which you can scrape off of a plaster wall to dehydrate the air in the can, and this makes a quite accurate meter to measure radiation. The exact dimensions, how to construct it, are given in the Nuclear War Survival Skills book. It takes a few hours to make one. High school students have made them. If you follow the directions, they're quite accurate, and they can be used anywhere in the shelter or outside the shelter. That's the lowest cost one that I know of. All right, the next lowest cost are probably the little fountain pen type dosimeters. They look like this. And it happens to be the kind of dosimeter that I'm currently using. And FEMA has developed a very neat little piezoelectric charging device. You squeeze the trigger, you generate electricity, and if your dosimeter is in the charger, when you squeeze the trigger, you can recharge it and set the little index back to 0 and so on. This is the one of the neatest developments in dosimetry that's come along in many years. That was developed by the government, and it's not available commercially. exactly analogous dosimeters and not exactly analogous but equally effective chargers are available from Dosimeter Corporation of America and from other manufacturers. Whether they're low cost or not depends on your point of view. The little pocket dosimeters, which tell you how much radiation you've been exposed to, and you read them intermittently in the shelter, outside the shelter. You can reset them so you can keep track of both your exposure and the rates. They cost anywhere from $60 to $100. For some people that's low cost, for some people that's too high a cost. Rate meters with dials that give you the actual ionizing rate at the time, again, are available from a number of manufacturers. The lowest cost ones that are reliable begin at around $400. The good ones cost $700 to $1,000. One of the best ones is made in Finland, and the last time I checked the price, it was about $400. So to some people, that's high price, and to others, it might be an acceptable price. I'm not aware of any dial reading rate meter that's available at anyways near $100.
Is the one available from Finland, is that distributed in the United States as well?
The one I showed here is stockpiled by FEMA. The model I have happens to be an experimental one that FEMA sent me to check it out. There are a number of us around the country that have these experimental models, and they are stockpiled and are available in case there would be a decision by the government to distribute them in a crisis. But they're kept in central warehouses, and you can't just walk down to the corner store and get one, no.
Thank you.
My question is about EMP. I'm concerned about personal computers and other electronic devices, and I'm wondering, you talked about the explosion that might happen, might be launched by the Soviets, specifically for the purpose of distributing EMP high in the atmosphere over the United States. I'm wondering what measures individuals can take to protect their computers and electronic equipment, and whether the EMP is transmitted down from the electrical power lines, or if it can just be picked up by a piece of equipment that's not connected to the mains.
The electromagnetic pulse, the EMP, is collected and transmitted by every metal object. It comes down the commercial power lines, it comes down the telephone lines, it comes down the flagpoles, it comes down the lightning rods. And for things that are not connected, they pick up the amount of EMP depending upon the length of antenna that they present. There have been some tests of commercially available small hand calculators and so on, to the simulated full field that you would expect from a high altitude nuclear burst. On the average, about half of them survive without any problem, and half of them don't. To my knowledge, there has not been a systematic evaluation of small electronics to make sure, which ones survive and which ones don't. I'm just, of the dozens and dozens of different manufacturers and so on that have been tested, just by accident, about half of them survive anyway, so nothing needs to be done. But you have no way of knowing that you happen to be have bought one of those lucky halves, and I have no way of telling you, because next year's manufacturing batch may be very different. I don't know. You can protect them by putting them in some kind of a Faraday cage. Any kind of metal will do that. Wrap them in a double layer of household aluminum foil is good enough. For things that have an antenna, anything that sticks out that's metal, it may be a deliberate antenna if you have a radio, or maybe an accidental antenna. It may be a power cord or a lead-in or ground wire or anything. You either have to have a way of disconnecting these antennas or putting in a surge arrestor to interrupt the EM pulse. There are commercially available now surge arrestors that are designed specifically for this, for arresting EMP. They're beginning to be available commercially from the people who make electronic piece parts.
I was wondering how a high altitude burst would compare with something that was on the ground, and whether it just propagates. In other words, something on the ground would, as you get further away, the EMP would be less, but something at high altitude. I'm just wondering, how dangerous it really is, and whether they are going to purposely target those weapons to, destroy all the electronics, or what you think about that.
All right. If you take a high altitude burst, the radiation emitted from the weapon interacts with the top of the atmosphere. The reaction zone at the top of the atmosphere takes place at around 20 to 40 miles of height. And then the EMP propagates directly downwards. So if you deliberately detonated a weapon, say at 300 miles altitude, the line of sight to where the interaction takes place with the top of the atmosphere is in the neighborhood of several hundred miles, perhaps 600 miles. The same intensity of signal is generated everywhere in that area, and it propagates directly downwards, so that everything in that area, which might be 500 or 600 miles in radius, receives the same intensity of EMP. It does not fall off with distance from the detonation point. It's only if you go to distances of several thousand miles that it begins to fall off. The electromagnetic pulse signal that's generated by high altitude detonation is expected to be in the neighborhood of 50,000 volts per meter. And that means that if you have an antenna which is 1 meter long, that antenna picks up a signal of 50,000 volts and propagates it to anything that antenna leads to. If you have a long commercial power line or a telephone line, it means you pick up electromagnetic signal, it builds up to the level that's permitted by corona discharge on your line. That's usually in the neighborhood of 2 or 3 million volts signal that you can expect to come down the lines. And those are the surges that you have to interrupt. And those are the surges that can affect very sensitive microcircuits and so on in computers or in handheld calculators. Now, in a lot of the equipment, you put in buffering circuits deliberately. They're put in there to buffer the surges in the power supply and so on. And those buffers work perfectly well against the EMP signal. And that's why, on a random basis, about half of all the small electronics survive. And that's because the manufacturer put in little buffer circuits to protect against the turn-on, turn-off surges from the power supply when you simply turn the on-off switch on. And in other cases, the buffering circuits turn out to not quite be adequate for EMP.
My last question is, what is the duration of the EMP?
All right. The one we're just discussing from the high altitude electromagnetic pulse, it lasts for about 1 microsecond, about 1/1,000,000th of a second. For surface bursts, which do not propagate the EMP very nearly as far because you have a point source rather than a large area source, the duration may be as long as a few milliseconds. So it lasts longer.
Thank you.
At this time, I'd like to ask Edward Francis to take the seat and moderate the questions, please.
Mr. York, the question I have, would you comment on the use of commercial steel tanks as a blast and/or fallout shelter for mass production of nuclear shelters?
A few years ago, I was involved in a study where we were examining the problem of how best to implement in as short a time as we could a blast shelter program for a large number of workers and a large number of the general population. And so we looked at the manufacturing capability of the United States in many different areas. And it was from this study we came to the conclusion that the corrugated metal best fit the United States manufacturing capability to mass produce large numbers of shelter components which could be shipped from the manufacturing plants and then assembled at the point where the shelters would be used by normal labor and normal construction methods. The steel, corrugated steel or corrugated aluminum, which is equally effective, are ideally suited for these kind of blast loads. They have the right kind of failure mechanism. The corrugated shape has already been developed by the manufacturers for the maximum strength for mass of the material used. They're easy to bolt together. They can be made waterproof by putting special compounds where the sections are bolted together. You can weld to them so that you can fit ventilation shafts, entrance doors, and so on. And at the time we did this study a few years ago, our conclusion was that by using about 10% of the steel manufacturing capability of the United States, we could produce enough of these shelters for the entire population in 5 years. So it would be possible to do this with very little perturbation of the existing manufacturing capability of the United States. It made it a very high priority item, and we're willing to divert more than 10% of the steel production capability. You could do it, of course, in a much shorter time.
If you were just to look at a local situation where you were not trying to mass produce for the whole country, but just in a local situation, would steel tanks perhaps serve your purpose?
The steel tanks will certainly serve the purpose. They can be shipped anywhere from the cities where they're stocked, and they can be assembled anywhere. But in the several cases where I've been involved in helping design and build one-of-a-kind shelters, it turned out in each of those cases it was slightly cheaper to go to reinforced concrete rather than the corrugated metal. The difference was not very large, but it was enough to be a decision in the owner of the shelter. And the main reason for that is the local availability of pre-mixed concrete, which can be delivered to your doorstep wherever you want it very cheaply. In a different location, you might come to the different decision as which was cheapest. The actual difference in price on few of a kind is going to be small. It won't be very much. There is one manufacturer in the United States right now who will deliver to your door a completely assembled, prefabricated, corrugated steel shelter, and he has designed it so it can be transported, assembled on a truck that will pass through all of the underpasses on the interstate highway system. And so That's one consideration. You might want to buy a shelter, that's completely prefabricated and assembled. And one manufacturer is selling those today. Nobody sells a completely assembled, prefabricated, reinforced concrete shelter. They're simply too heavy to transport, so you always build those in place. There are people who will sell you the designs and all of the steel work and all the doors and everything, so that all you have to do is assemble it on site and pour the concrete.
Can you give us the name of this corrugated steel manufacturer?
All of the major steel manufacturers make the corrugated steel for culverts and so on.
I was referring to the one who produces the in-product shelter.
Yes, that's Barbier in Washington, D.C. And he has a franchised outlet in Portland, in Oregon also. But Barbier is the name of the company, and also the designer.
Thank you.
Several months ago, I tried to reach the Philadelphia FEMA office, and I got no response whatsoever. Can you give me the present status of FEMA nationally? And also, of all the plans and studies that FEMA is carrying out, are they, or if any, or all, how are they available to the public?
The FEMA program is continuing very much as it has in the past. They are funding and sponsoring a considerable number of analytical studies on relocation, shelter design, medical problems, recovery, and so on. Each of the 10 regional offices keeps on hand a very good library of available government publications. Quite a number of these are available right at the regional office. I'm sorry, I don't know which of the regional offices is closest to where you live. If the one in Philadelphia was the one you should reach, and they weren't available, I would assume that there's been some change in the telephone system, and you would have to track down a current, effective telephone number for them. But if you can visit the regional office, if it's not out of the question, all of them have quite a good library, and most of them have a fair stock of documents on hand. Some of them are available at no charge. All of them are available from the U.S. government printing office, at cost. And most federal office buildings, every large city at least has a federal office building. And in all of the federal office buildings, somewhere in that building, there's a librarian who has a card catalog of all the pertinent documents that are available from the U.S. government printing office. Now, the other thing is to write to the U.S. government printing office and ask to be on their distribution list. And you can get from them an enormous index of available documents.
We're aware that the sunlight has effects that are beneficial to human health. Inside a shelter for any extended period of time, what measures do we need to take to compensate for being underground that long, if any?
One-a-day vitamins.
One-a-day vitamins. No full spectrum lighting or anything like that? Okay.
No, the human deficiency diseases for lack of sunlight take years to develop. And so you're not going to be in a shelter that long, and so just normal one-a-day vitamins, extra vitamin C, extra vitamin D, if you happen to be one of the people that need that, and that will prevent the deficiency diseases for months and months and months.
And given the 1 week marginal zone that you allow yourself for building your shelter, what do you think it would take in time to effectively put in a U.S. shelter program if we really went gung-ho?
Really, all-out shelter program for the United States as a whole, I see about 5 years as about the minimum time to implement that. The magnitude of such a shelter program is comparable to the interstate highway program and would take about the same time to implement.
Thank you very much.
The question I had was regarding the FEMA, and I'd like to state a little more information in regard to the previous question, that FEMA does have a university that you can send for home study courses. They are free. I have the address, I don't have it with me, but it's to be an emergency manager, and you can be trained on different levels. You can take the test and they will send you some more home study programs. I found when doing some research in Washington, D.C., that it was very difficult to get anything out of FEMA because they don't have any money. They do have a few booklets that were available and will make available to the public, but you have to print them yourself. And they're willing to give you that information printed. Now, the question that I had is that you have mentioned a number of times of the research that FEMA is currently engaged in. Is that something they continually are actively engaged in? Do they have a little bit of funding to do this kind of research?
Yes, they have a little bit of budget. The overall FEMA budget hovers around $100 million a year. And some years it's a little more than $100 million, and some years it's a little less than that. I don't happen to know what the current budget this year is. Right now, that has to go to all of the FEMA activities, which include the National Fire Prevention, Hurricane Alert, emergency alerting systems, as well as the civil defense. They are able to sponsor each year 8 or 10 studies in the range of $100,000 to $200,000 on each study in this area. So they're able to devote a few million dollars a year to continuing research. And generally the research is quite well directed and quite well managed, and the people who do it are very knowledgeable and work very hard. And they generate documents. And the documents, as you pointed out, you may have to go to the government printing office to get the documents. You have to find out what they are, and you can do this through one of the ASTIC listings or one of the DAISY Act listings, find out the documents, and then order them from the government printing office. And FEMA also has a school at Emmitsburg on the East Coast each summer, where their university on campus trains the emergency managers too, as well as their correspondence courses. And a fair part of their budget available for civil defense goes to that training program each summer.
Thank you. Yeah, the only problem that I found, most of the people that I talked to were very well intended and very committed to the work that they were doing. However, there was no way of getting the information out to the public so that other people could become informed or to do something about the situation, or even become aware that there is no civil defense.
No, your observations are quite correct. I agree with you. And it takes some effort to get the references you want, and then some effort to obtain them.
You have any suggestion as to what can be done by the public in order to disseminate that information more readily, make it available?
There are only two ways I'm aware of. One of them is to go to the effort yourself to obtain the documents that you want, and then to have an organization sponsor the publication and distribution of them. And that's what's actually being done today on a few documents. The other way is to get enough people to bring enough pressure on Congress to get Congress to increase FEMA's budget.
Okay, thank you very much.
Yeah, my question is there any way, any construction techniques or any technology to keep an underground shelter dry in the way of humidity from condensation, not necessarily from water leaks outside, but from condensation due to temperature changes to keep it down, keep the moisture down, without any kind of mechanical devices like humidifiers or chemical, something that would be built into construction where it'd be passive and whether you're living there or not, you know, or actually in the shelter, keep it dry.
The people who design and build the underground housing have tackled this problem, and they have developed a waterproof insulation which you put on the outside of your concrete or your metal walls. It's about an inch thick, and it really solves the heating and cooling problem, the condensation which comes from cooling of your concrete walls underground. It's required now in the building codes in some localities whenever you build a partially underground house. That's the most effective method that I know of. You can add porous concrete to part of your wall thickness, or as an insulating layer around the outside of a metal shelter, which would also be effective. But this commercially available insulation material seems to be the best that's available. And even though it saturates with water and it drips out the bottom into a drain, you have to have a drain for it to drain into, it prevents almost all of the condensation from inside your concrete walls. Other than that, it takes dry air, and that requires either dry air circulation or a dehumidifier in the room. There just are no magic ways.
Okay, thank you.
I wanted to ask you if when would livestock or game animals be acceptable to eat? They've been exposed to radiation.
If animals have been exposed to radiation, the radiation itself does no damage to the tissue in terms of food value. It may damage the cells and cause sickness or death in the animal itself. But the ingestion of food into the animal, from eating contaminated hay or grain, does not transfer any contamination into the red meat. And so the red meat of animals is safe to eat no matter how badly they've been exposed, always. The radioactive isotopes that are taken up tend to concentrate in the bones and in some of the organs. But I'm not aware of any uptake in any of the muscle itself, and so at least a portion of the animal is always safe to eat.
How about into the fat tissue? Is some of it concentrated in the fat tissue?
I do not know one way or the other. I haven't read of it either way. I'm sorry, I don't know the answer.
How about fish or poultry?
Poultry is the same way. The isotopes are not taken up into the meat. They're primarily either specific organ seekers, such as the thyroid, or are bone seekers. They're not incorporated into normal tissue. Fish have a very large content of water. Most fish is primarily water and not much food value in reality. And if they're living in contaminated water, they tend to get contaminated water all through their tissues, and so it's much more difficult to have assurance that fish are safe to eat.
Also, another question I have is, would EMP stop automobiles running on the highways? I mean, I saw it in a propaganda film, and I thought I'd ask this question.
A lot of modern automobiles have electronic ignition systems that are computer controlled. it is possible that the EMP could couple into the electronic controls and cause the automobile to shut off. Now, whether it will actually happen or not, we don't know. One automobile manufacturer built a simulated EMP test chamber big enough that he can put his automobiles in it, run them under all kinds of road conditions on a turn wheel, and test them to simulated EMP. I don't know that he actually incorporates his test findings into the production models, but at least they have thought about the problem and gone to the expense of building a test chamber to test the automobiles, and so I presume that they incorporate the test findings into the automobile itself, but I have no knowledge whether they do or do not. So I think that the majority of automobiles will not be affected by EMP, but I do not have the evidence to say yes or no.
Great, thank you. I had one additional question on EMP, and that was if something like a flagpole or power line, railroad tracks, things of that sort, so to speak, act as collectors or antennas for the EMP that's coming down from up above. And it's, I think you said 50,000 volts per square meter.
Per linear meter. Per
linear meter. The question is, if you were standing on the ground holding on to a telephone pole, let's just say, when the electromagnetic pulse was created, could you be electrocuted?
Not from the EMP itself, because the other characteristic is its very short duration. Okay, and so the energy content depends both on the voltage level and on the duration, and it's not enough to directly damage a human being.
Would you even feel it?
You wouldn't even feel it.
Wouldn't even feel it.
Now, when you're talking about you're leaning on the power pole, one of the things that the EMP can do is create a high enough voltage to cause an arc over of the power. Now, if the geometry happens to be such that the arc continues to ground through you, then the energy from the commercial power line is more than enough to electrocute you. So
we could arc over from a power line to a flagpole, let's say, and
well, it can only arc certain distances,
yeah.
and the standard safety features of building power lines prevents that from being possible.
Mm-hmm.
But it could arc to a tree limb and down a wet tree to that kind of thing. But so it's possible that the EMP can trigger a power release from the commercial power lines, and then that release can be hazardous.
But the EMP itself is such a short-lived spike, so to speak, of electricity that you couldn't even feel it.
No.
Okay.
Many of us live in very highly industrialized areas, and in spite of your stated the diseconomy of our enemy delivering chemical and biological weapons to us, and therefore the lack of having to prepare for them, would not in fact a nuclear attack that would disable our industrial capacity also potentially release very toxic chemical effects into our environment, and therefore render it necessary for us to protect ourselves from that kind of chemical infestation?
No, an excellent point, and you're quite correct. Anything that would destroy a warehouse or factory building or tank car or truck car on the road and cause it to rupture and release hazardous chemicals could be a very real concern. You're right. And it could well happen that the blast effects from a nuclear attack on our industrial areas would release the toxins that are stored there. And it's a very good point. I'm glad you brought it up.
Mm-hmm. The second thing I ask is relates to the EMP effect on automobiles, and whether or not the military, the United States military, even in spite of a lack of knowledge of the effect of EMP on the electronics on autos, have taken precautions for their own military equipment that has to carry the same kind of electronic equipment, ignitions, so forth.
Okay, the answer is yes. Every military system, every new procurement has to pass through a decision gate. If that equipment or that system is considered essential for post-attack, then it is EMP protected. Now, sometimes the system is considered not essential for post-attack. Now, I don't know any examples right now offhand, but in that case, they would not spend the money to EMP protect it. But the majority of military communication equipment, operating equipment, and so on is either already protected or is in the process of being protected right now. The problem has been recognized by the military, and they are working on it.
And in relation to that, are there specific kinds of add-on systems that a person could put onto their automobile, say, that would protect its electronic systems? Or if there were not those types of things, are there types of automobiles that one should buy that eliminate that kind of problem?
Old-fashioned automobiles with non-electronic controls are immune. Yes, there are commercial items you can buy to protect your automobile, and right now there's no way of knowing if it's protected or not, I'm afraid. Mm-hmm. The main thing is to make sure that the housing around the sensitive electronics is metal, not plastic. And many of the devices are in plastic houses, so that means you have to find a way of putting metal around them to keep the direct pickup of EMP away from them. Mm-hmm. And then the second thing is, if there are input leads coming into the electronic package, which might pick up a charge and carry it in, you have to find a way of either shielding that lead, mm-hmm, so it doesn't pick up, using shielded wire to replace it, or putting one of these little surge arresters, mm-hmm, into it. Mm-hmm. And they look like little buttons. They're about that size.
And a surge arrestor, is that a fairly simple thing to install, or no?
Well, it's you have to cut the wire, right, and solder to the two ends of the surge arrestor, and then make a third connection on the surge arrestor to a good ground on your automobile or wherever it is, and then make sure that all of the leads are very, very short. Mm. And so it takes a little bit of care in doing it. There are manuals written which go into this in detail, about what has to be done. Bell Labs puts out a very excellent manual on this.
Good, thank you.
I was wondering if you would compare for us the amount of earth movement of an earthquake relative to an EMP shock, not an EMP, but a blast shock that we might get in a shelter.
On a earthquake like the ones in the very damaging earthquakes in California of a few years ago, there were places along the fault line where the earth shift was several feet. There were places on the highway system overpasses where earth shift of the order of 1 foot was enough to bring down the overpasses. That kind of earth motion will occur at a distance of about, say, 1/4 of a mile from a 1 megaton weapon detonation, in the range of 1/4 of a mile to 1/3 of a mile, that kind of distance. At a distance of 1 mile, the earth motions that will be induced by a nuclear weapon are the order of 2 to 6 inches at the surface, and it's mostly vertical up and down motion. There's not much difference in the motion at one location compared to the motion 10 feet away, so there's not much shearing action on pipes or your underground utilities and so on. The whole area moves up and down pretty much the same. When you're farther away than, say, 1 mile from a nuclear detonation, the earth motion is entirely negligible compared to other effects. Whereas an earthquake, the motions can extend, as you know, for hundreds of miles.
Since the time you're going to spend in the shelter is dependent on what's going on in the world around you, really, has anybody done any intelligent work to figure out how long the Soviets intend for people to survive in their shelters?
If we knew the Soviet intentions, what they plan to do, it would make all of these plannings and studies much, much simpler. There are scenarios. We look at hundreds of different possible attacks. We call each one of a scenario. There are scenarios where we postulate that the Soviets deliberately, continually send in weapons week after week after week, deliberately to prevent recovery and so on. If they choose this as a particular method of attack, they have the capability of continually adding fallout to portions of our country that could force people to stay in shelters for 6 months to a year. They certainly have that capability. They do not have the capability to do that to more than a small fraction of the United States. They simply don't have the weapons in their arsenal to do it. But they could do it in selected areas. Say they wanted to isolate a few hundred square miles. They could certainly do it in an area of that size. Whether they intend to do it, I have no idea.
Okay, back to EMP again. Is it possible for EMP to erase the magnetic tape or a computer disk?
Yes, it is possible.
Now, if you're going to build a Faraday cage to protect such things, what is the minimum grid that you need to have on the cage rather than just a solid piece of metal? Can you get by with a wire mesh?
Yes. Normally, the finer the mesh, the better. But you also like to have welded intersections on the mesh if you can. The smallest mesh you can buy at the hardware store, which has welded intersection, is 1/4-inch hardware cloth. That's fine enough. We don't know of any effects that will get through a couple of layers of 1/4-inch hardware cloth. And to be on the safe side, you also add aluminum foil.
Okay, which auto company was that has a test chamber?
I don't think I'm at liberty to say.
Okay, finally, I work in design of water systems, and if we're going to be hanging around in our shelters for 6 months, perhaps, maybe the trash bag disposal of waste would not be adequate. One thought that occurred to me was a composting toilet, which could be built into the structure and might last for that long. Do you have some other ideas for long-term waste when the outside radiation is pretty high?
I think the best way is if you can pump your waste up to your normal septic system, or build a comparable septic system just for your shelter. And the second best is, just as you suggested, the composting systems. The Swedish system has been tried and works very well, and I see no reason why something similar to that, wouldn't work quite well. And then probably the next best are the chemical solution disinfectant type of disposal systems, and then the plastic bag throw-out system is probably the least desirable. but it's also has the advantage of being the cheapest, and it will work for a while.
I'm very grateful for your coming and giving us this information. Thank you very much.
I have a few questions. The first one is, you mentioned the Mars frequencies, or Mars system for communication as being one source of information. How do we find out their frequencies? Those, them, and also other possible sources of information through the radio.
Contact your nearest ham operator and ask him. And if you don't happen to know one, go down to the nearest Radio Shack and ask the clerks there who's their most prolific ham. Because they have a frequency band that's allocated to the Mars program, but I don't know the individual frequencies that are assigned within that band. And each operator has his own frequency that's assigned for transmitting.
What about as far as the regular AM stations or the standard stations that have been hardened for to handle EMP?
I'm not aware that any of the standard commercial stations have gone to any trouble of hardening. No. Now the transmitters of most of the radio stations and most of the TV stations, the transmitters themselves are quite rugged. So these are high power, high voltage systems, and EMP is not going to bother the transmitter itself. It's made to survive direct lightning strikes on the tower, and does. And so if there's any way of getting an emergency mobile transmitter, generating station out to the transmitter, then they can be back on the air. Now, blast effects may knock the transmitting towers down, so there may not be any tower and you're out of business anyway. But I would not expect the commercial radio and TV stations to survive as far as I know about them at present.
So basically the Mars and the ham system would be the only reliable source as far as you know. I mean,
the regional FEMA centers all have hardened communication facilities. They're all hardened to EMP, and the majority of them are also hardened to blast.
How can you get their frequencies? It's through the local ham radio operator?
The FEMA will broadcast on the assigned emergency broadcast frequency. That's standard, 1620 kilocycles or something. I'm sorry, I don't know the number for sure, but there is.
I'll double check it.
But they will broadcast on that, and then they will also broadcast on their assigned FEMA frequencies. And contact.
Those are on the AM dial, generally?
There's one on the AM dial. Generally, they're up in the shortwave region. And so, but they'll have the capability to broadcast on the standard allocated frequency. And I'm sorry, I don't remember the number exactly. But you would have to contact local regional FEMA and ask them what the frequency is.
Okay. My next question is that I've heard that it's possible to scrape off a certain amount of the topsoil in order to start growing in the soil again, after the fallout's hit. One person said it was about 2 inches of soil. You can basically scrape off 2 inches of soil off a certain area of land and then start regrowing again. And is that true as far as you know?
No, that's quite true, because the majority of the fallout is trapped in the soil particles, and that just falls back on top of the soil as dust, grains of soil. And if you have the equipment to scrape off the top few inches, carry it away somewhere else, then the soil under it is not contaminated. Now, in a lot of farmland, that's possible. You can scrape off a few inches and have many inches of topsoil left. Where I live, if I scrape off the top 2 inches, I'm down to bedrock. So.
Okay. You mentioned that you have the circular slide rules that have various capabilities of calculating, different blast effects and stuff. Where can you get those from? From FEMA again, or is that through the government?
No, that's a different agency. The government printing office publishes this effects of nuclear weapons, and the address is in the front of this one. It comes with this particular little computer comes attached. So when you buy the book, you get the computer for free. Now the others, this one, which is more elaborate, is published by the Defense Nuclear Agency.
And that's the government.
And that's a government agency. And I don't see any instructions on it for how to obtain them. The headquarters, Defense Nuclear Agency, is in Washington, D.C., out on Telegraph Road. These computers are distributed for them by a company named Horizons Incorporated.
Okay, another question. You mentioned that the Swiss shelters have their water tanks supported by climbing ropes. Is that just purely for shock reasons? Would there be a problem with having them, firmly fixed to the top of the shelter, or that?
No, that's for shock mounting. You want some rattle space, and that was just an easy way of getting rattle space.
Okay, so for a fallout shelter, it wouldn't be critical, but for a blast shelter, it would be. Make
That's
sure
right.
Rupture.
You don't, and the Swiss shelters are all also blast shelters.
Okay. One last question. Do you have any suggestions on ways that we could get Congress to give the civil defense a little more priority as far as financial spending, as far as actually implementing some of the civil defense, other than just writing a congressman? Are there any bills or anything like that we can be pushing to get passed or something?
Well, the Congress responds directly to voters, writing letters to your congressman, as many congressmen as you can, and they respond to lobbyists. So if you can spend time in Washington to go knock on their door, or as a group find a way of sponsoring someone who can spend time in Washington and knock on the door, those are the two things they respond to, either the voters or the lobbyists. And one takes, letters to the congressman, and the other one takes presents in Washington.
Okay, thank you very much.
I didn't fully hear your answer to the gentleman who asked about livestock. You may have already answered my question. But can you recommend any precautions for the genetic safety of livestock, especially horses?
The question on livestock was, the first question was when it would be safe to eat the animals that had been killed, use them for food. If you can avoid the direct contamination of fallout, which would be on the skin of the animals, and contamination by some of the internal organs which take up the isotopes, that the major portion of the muscle meat, the red meat of animals, is safe always. That it does not take up any of the hazardous radioactive isotopes. For genetic effects, we just don't know what the genetic effects on future generations might be. The only evidence we have so far is that the genetic effects are small. The largest population of humans that we have are the Japanese who survived Hiroshima and Nagasaki. So far, there are no genetic anomalies that are statistically significantly different than those in the normal population. So the only evidence we can have is say that any genetic effects are small. On animal experiments, it's measurable. And because they expose enough generations of animals to accumulate genetic effects, and it shows up as a statistical increase above what the normal population would have. To prevent genetic effects due to radiation, the only way I would know of would be to prevent radiation to the animals as best you can. And that would mean keeping them inside shelters, inside barns, and out of the open fields as much as you could until the fallout is decreased, and feeding them non-contaminated hay that's been stored in barns and free from fallout, as long as you could. But I don't know of any specific methods that you might use.
Okay, thank you. My next question is, where is the Dosimeter Corporation of America?
I'm sorry, my memory isn't good enough. I don't remember where they're located. I'm sorry. They're in every major library. There are manufacturing guides, and you can look in the guides and find people who manufacture everything. These are very thick volumes, and there are some last time I checked the index, there were some 435,000 manufacturing companies in the United States with more than 10 employees, and you've got to wade through all of those to find the one you want. There's an office in Oak Ridge that keep a continual updated list of manufacturers of all equipment.
Thank you.
I heard it mentioned about bentonite clay being used as a filtering system. I have also heard of using bentonite clay mixed and drinking the murky portion as a cleanser of heavy substances within the body. So that brought me to thinking that it may be possible to use this bentonite clay for anyone who may have taken in radiation through food, or even as a cleansing substance during the time of having to be in a fallout shelter. What's your opinion on this?
I'm not aware of any studies that have measured directly the effectiveness of bentonite clay. There have been agents that have been developed specifically for this, for leaching out, radioactive elements that have been taken up, and they are quite effective. Certainly, the bentonite clay would have some effect. I just have not seen any studies of quantitatively what it might be, and I know of no adverse effect. I don't know of any harm that would come from it, and so it's worth trying. The one thing that can be done to prevent uptake of the radioisotopes is to protect the thyroid from radioactive iodine. And you can do that by saturating the thyroid by taking potassium iodide ahead of time or before you would be exposed to ingesting any of the radioactive fallout. And that's available from 2 or 3 supply places around the country.
Thank you. I'm grateful for your time.
Thank you.
Do you know of any studies, or what is your personal opinion about the use of fiber optic cables, or a cluster of fiber optic cables, to actually bring sunlight into the shelter? Perhaps just for psychological reasons, or just for a minimum amount of light for sprouting or that sort of thing? Or lighting.
Yes.
Is that a good idea?
Yes, it's been looked at, and it looks very practical and very feasible.
Thank you.
You mentioned that the power factor is the power factor strictly for radiation, or is it for blast also?
The PF stands for protection factor, and it's used only for radiation.
Okay. You also mentioned that the protection factor of 200 would eliminate all radiation inside the shelter. Is that true? Did I get that right?
That's misleading if I gave that answer. Protection factor of 200 is enough to prevent serious medical problems from the radiation. There will be radiation inside the shelter, if you have a protection factor of 10,000, there will still be radiation inside the shelter, it's just less. The PF of 200 is enough to save everybody's life. Nobody will die.
Is there a factor that would eliminate all minor medical problems?
I personally think that a factor of 1,000 is enough to prevent any problems that are of concern to the majority of people. The radiation exposures that you would get are going to be in the order of a few tens of rad with that kind of protection factor. All right. Some people, well, the statistics indicate that if you're exposed to 1 rad of radiation dose, it increases your chances of sometime getting a cancer by 1 in a million. That is, if you have 1 million people, they're all exposed to 1 rad, eventually there will be 1 more cancer in that population than there would have been otherwise. And so if you're exposed to 100 rads, which is the threshold of the nausea and vomiting, then you'd increase your chances by 1 in 10,000 of getting a cancer sometime.
Good. Where did the protection factor come from? Is that your study and research, or is that in a book?
No, that has just become accepted jargon over the last 2 or 3 decades by people working in this field as a easier way of saying shielding factor or protection factor, and it just happens that PF came to be the one that was used in some of the earliest publications, and other people have just used it since then. I don't know who first originated it, but it was certainly 25 years ago or more.
You mentioned the power factor of earth, but I don't think you mentioned that of reinforced concrete. Do you happen to know what it is?
Yes. The shielding or the protection factor is directly proportional to the density of the material. Ordinary soil has a density of about 100 pounds per cubic foot and has a protection factor of about a factor of 10 for each foot of thickness. Most concrete has a density of about 144 pounds per cubic foot. And so 10 inches of concrete will
12 inches.
I'm saying 10 inches of concrete would do the same as 14.4 inches of soil. And so it takes, if you divide 1 foot 12 inches by 1.4, which is about 8 inches of concrete, does about the same as 1 foot of soil. And any other material is the same way. If you use water, which is 62 pounds per cubic foot, you have to use 1.5 times the thickness as you would of soil.
Good. A previous speaker mentioned that a two-layer grid of reinforcing in concrete at 6 inches on center each way would be enough of a net to arrest all incoming EMP. Have you heard of that? Do you agree?
We've actually done a large number of tests using that kind of reinforcing grid, and over a normal shelter, it'll provide an attenuation to the EMP signal of 30 to 40 decibels attenuation. To be sure of having absolute protection of all your equipment, you need about 80 decibels of attenuation. Since a lot of equipment will survive even with no protection, and if you use 2 layers of your rebar and you get 30 or 40 dB, then you can be sure that almost all of your equipment is okay. But it does not provide high confidence for all equipment. But
Okay.
yes, it is quite effective, and it's been validated by very large-scale experiments.
Good. Last question. Have you heard of a periscope used for a post-nuclear worldview?
I've heard of people proposing that you have a periscope so you can look up through your shelter. I don't know of anyone that's selling them commercially. You can certainly make one very simply with 2 flat pieces of mirror and a line of sight pipe between them. And if you want a full view, you can put a lens up at your top mirror and make a camera oscuro, and those were quite popular around the world 100 years ago.
Good. Thank you very much.
Would you comment on the potential for contamination of water wells from fallout?
If you have a deep water well where you're getting your water from an aquifer, there's no contamination in the short term. Now, if you have a shallow water well where you're exposed to surface runoff, there'll be contamination immediately. And on your deep aquifers, the surface runoff will get into the source of the aquifer, and then it depends on how long the migration time is from the source to where you're tapping the water. Where I happen to live, the migration time of the aquifer is thought to be about 8,000 years, and so I don't think the contamination problem is going to be serious on that. And I do have a deep well below a very good impervious layer. But it just depends on the aquifer.
Can radiation pass through the well cap and go down through the well casing into the aquifer?
No. The radiation is trapped in the fallout particles, in the dust and the dirt. And if your well cap is tight to keep the particles from falling in, if it's dust tight, then there's no contamination can get in through the well cap.
So you would recommend a sanitary type well cap to keep dust from being able to enter the well?
It's mandatory in every water district that I'm aware of, but yes, I recommend it.
Okay, thank you.
Being a ham radio operator, I was very interested in the publication you mentioned about hardening radio equipment, but I don't believe you mentioned the name of it. Do you recall the title?
Well, what I had meant to say was that a group of us had put together a pamphlet on this, and I sent it to the Ohio District Civil Defense Management Agency, who were coordinating this Mars effort to protect the radio equipment. To my knowledge, it has not been published as a formal release document, but it was the Ohio District Civil Defense that were coordinating and spearheading this effort.
Well, if it's ever published, the hams will get a hold of it. Is there a threshold frequency or maybe a minimum antenna length for a radio that would be immune to EMP?
No, it depends on how sensitive the first stage of your electronics are on the antenna. And so every input section has some kind of vulnerability threshold, and if the antenna is shorter than that threshold, then you're no problem if it's longer. But there are no two radios have the same threshold.
It's purely individual then?
Yes.
Okay. You mentioned the voltage and the duration of the EMP, but you didn't mention the amperage. Do you happen to know what that would be?
The amperage depends on the size of the wire carrying the current, and so you have a voltage which is impressed on the conductor, and the conductor has a certain impedance, and so that voltage produces whatever current it produces in that impedance. On a typical vertical tower structure for an antenna, the currents are in the neighborhood of 10 to 20,000 amperes of current. On an individual wire, the currents typically are of the order of 10 amps.
Enough to fry most equipment.
Yes.
In the past, there's been a problem with radiological meters with small scale saturating, and then it gives the illusion that the radiation has dissipated when in fact the meter merely saturated and went to zero. Are the new meters, are they engineered around that problem now, or is that still a problem with the low-scale meters?
That's why when I was asked the cost of a reliable meter, I said I wasn't aware of any that cost less than around $400 that were reliable. There are meters you can buy for as low as $20, but they're very vulnerable to the problem that you just mentioned.
Okay. Thank you very much.